The Earth has a moon. Galileo discovered 4 moons of Jupiter. Now, Jupiter has way more than 4 moons, but the other moons are very small, and it took a very long time until telescopes were big enough to see them. Saturn has one big moon, and then it has 7 medium-sized moons, and then a whole bunch of little tiny moons. So in modest telescopes, you can sometimes see up to 8 moons of Saturn. So interestingly enough, you got 8 on Saturn, 4 on Jupiter, and 1 on Earth. Mars is in between. And so, in some writings by by Jonathan Swift, famous for Gulliver's Travels, he mentions 2 moons of Mars. Well, that makes a pattern: 1, 2, 4, 8 from Earth outwards. And so that seemed to fit the pattern right there. Now, it really doesn't fit the pattern because it turns out that Jupiter, we're now up like close to 70 moons, and similar to do that for Saturn. It's just that it took much bigger telescopes to see the other moons that were out there. So the outer worlds all have a huge number of moons and very big moons. Earth has a very large moon, which doesn't really fit within the rest of the solar system. But planets that small don't normally have moons that big. And so it did raise an interesting question, because it's like, well, Mars is so much like Earth, why didn't it have a moon? And so there would have been hunting for a moon for a very long time. And then eventually what happened was Asaph Hall, the Naval Observatory, actually discovered 2 little specks that orbit Mars. And so they finally found Mars that did have some natural satellites. Okay, now calling them moons is a little bit much because they're tiny little things, just teeny tiny little specks. Most likely they're asteroids that get caught by the Martian gravity. Remember, Mars is pretty close to the asteroid belt. The moons were named Deimos and Phobos. That means terror and fear. And so supposedly the names of horses that were pulling the chariot of the god Mars. And here in size, you can see, that bar there's a 10-kilometer size bar. So 10 kilometers, about 6 miles. So, one of them is just a few miles across. The other one is, like a dozen or so miles across. So we're not talking very big things here. Tiny little specks. And the interesting thing is that they orbit pretty close. For example, Phobos orbits Mars in only about 7.66 hours. And Deimos orbits in about 30 and a third hours. So what does that mean? Well, that means that as Phobos is orbiting, Mars is turning, so that means it orbits every 7.66 hours, but as it goes around, then you have the planet turning as well. And so the end thing is it actually goes through a complete cycle of phases every 11 hours. And so that's one lunation, so one cycle of the phases. So that's what it looks like it's doing. Deimos orbits here in about 30 and a third hours, so it takes about 5.4 days. Now the thing is that what happens is that that essentially means you see Phobos go past you every 11 hours. So again, that means that it'll go around more than twice a day. So and then Deimos goes around, it looks like goes around about every 5 days or so. That means it takes 2.5 days. It's up, as the planet's turning, then the moon is going around, and so that means it's up for like 2.5 days. The sun rises and sets 2.5 times, while the moon stays in the sky. So it rises in the east with the sun sets in the west, the moon's by that point only midway up the sky, sun rises again, sets in the west as the moon is getting in the western sky, sun rises again in the east, and then the moon sets just before sunset. That's what Deimos is doing, whereas Phobos, it rises, goes across the sky, then sets. And so it's really interesting how, I guess, trying to make a calendar out of all that. So there they are drawn to scale. And it's going to be really hard to see on your screen, but there's a little tiny little dot right there with the name Phobos written next to it. And there's a tiny little dot right there with the name Deimos written next to it. And they're really calling these things moons is a big stretch. They're nothing like Earth's moon. They don't have enough gravity to make tides on Mars. They're just little tiny little specks of rock. Almost certainly they are small asteroids that got caught by Martian gravity. They're almost certainly not natively formed there. So studying them is a study of the Martian studying the Martian environment and the asteroids around there. In fact, a Soviet mission, Phobos 1 and Phobos 2, were actually designed to orbit Mars and study Phobos. So they were going to study Mars and the moon. One of them was lost on the way to Mars. One of them actually arrived at Mars, went into orbit, collected a little bit of data about Mars, but as it was approaching Phobos, it had a lander. It was going to land on the moon, and it lost contact as it was positioning itself to deploy the probe. So we don't really know what happened. It just quit working. Phobos is so small, though, that if you were actually standing on Phobos and jumped, if you can jump about 2 feet high, from the ground, that's enough force that it actually launch you completely off of Phobos into orbit around Mars. That's how little gravity the thing has. And so that gives you an idea as to just how tiny it is. High-resolution pictures of Phobos by our orbiting spacecraft show that it has a giant impact feature on one end of it right here, and cracks which run across like that. It appears like the impact nearly broke the thing into bits. So that was a large impact for such a small object right there. That's actually from the surface of Mars. One of the rovers was looking up, and one of the moons just happened to pass directly in front of the sun. So that's what a Martian eclipse looks like. These moons, even though they're much, much closer to Mars than Earth's moon is to Earth, they are so small that they don't cover the sun, even though the sun looks a lot smaller from Mars than it does from Earth. So there we have a Martian eclipse. Now, if you remember, on Earth is rotating and the moon is going around, but Earth is rotating fast and the moon goes around, and so that means it pulls forward on the moon, which means that our moon is gradually spiraling outwards an inch or so per year. On the other hand, Phobos goes around Mars faster than Mars rotates. And so that means it's going to behave entirely differently. So what's going to happen is that for Phobos, we have Mars rotating, but the moon is going around faster, and so that means that any kind of tidal forces are pulling backwards on Phobos, which means that Phobos is gradually spiraling inwards closer to Mars. So it's actually getting closer about 6 feet per century. So that's considerably impressive right there. So 6 feet per century, that means that that's going to actually run into Mars, if you do the calculations, in about 50 million years. Now that it might actually fall apart into a ring system. We'll talk about how rings work when we get around to Saturn. So the future of Phobos might not be that it actually impacts Mars, but it might break apart into a ring around Mars, and then little small things, come raining down. Or it might run into Mars, in fact, if it's solid enough put together, which I don't think it is, given the cracks that are on it. But if it is solid enough put together, it might actually impact Mars and give another large impact feature, such as Argyre Planitia or something. And so, if so, then the distant future, you'd have another marking on Mars to study. But as of right now, we just know that it is doomed, and it is going to eventually smash into Mars or be ripped apart.